There you go. So what you want to be looking for is a D or DEG at the top. My calculator, I just press the mode button, press mode again, and you don't want R. You don't want radians or gradients. You want degrees, so I would select 1 on my calculator and then make sure there's a D at the top. Some of you have a DRG button, like it's actually on the calculator. If you just press it until it gets to degrees, that gets you there. If you don't know how to do it, I'm pretty good. I've seen a lot of calculators over my years, so I can help you out with that. So one test you can do is go sine of 30. You should get 0.5. And some of you are like, I can't do that, Mr. Dirksen. My calculator doesn't work. It gives me an error. You have to do it backwards. You have to go 30 and then press sine, and you should get 0.5. So it depends on what kind of calculator you have. Now we're good. Alrighty. Now we have that out of the way, we can start. It's gonna be, I think it's gonna be fun. I think you can enjoy it after a while. So we're gonna deal with sine law and cosine law. Those are the only two you're gonna ever use in this course. You're like, what about tangent law? There's no tangent law. Sine law and cosine law is all you need. You used to do SOHCAHTOA. We're not using that in this course. And so I state that very clearly at the beginning, because some students, it happens especially on the exam. For some reason, you draw a blank and students go back to SOHCAHTOA on the exam. And I'm like, I've never even taught this, right? So you're so used to it from the previous grades. So since we're working primarily with oblique triangles, what in the world is an oblique triangle? It's just a triangle that isn't a right triangle. There's no 90-degree angle, okay? We will not be using primary trig ratios, right? SOHCAHTOA, do not use them, okay? Very important that you remember that. Right? You know what SOHCAHTOA is? Raise your hand if you've heard SOHCAHTOA before. Yeah, there you go. See? If you had me or somebody else, SOHCAHTOA is it's popular acronym to help you remember which one to use when. You're not going to need that, okay? I'm not saying that trig is wrong. It's just that's not what this course is focusing on. So let's flip to the back side here. These are inserts. You can tell that this is a booklet, but I insert a lot and I delete a lot because it's irrelevant. So just flip to the back side. These are things you should already know at this point, but I'm just going to review it. The sum of interior angles is always 180 degrees. So do this, please. So if you have a triangle that looks like this, right? If I told you that this is 50 degrees, angles are measured in degrees. Remember that? It's the measure of the opening between two lines. So if this is 50 and let's say this is 40, no, we don't want 40. We want, I'm going to go 35, right? If you have two angles, this is unknown to me here, but it's not a big deal, right? Because I can figure out question mark. How could I figure that out? Well, knowing that they're always going to add up to 180, I'm going to go 180 minus 50 minus 35. I don't usually use question mark as my variable, but in this case, right? So 180 minus 50 is 130, minus 35 is 95 degrees, right? So if you have two angles, you can find the third no problem using this property. Then there are three types of triangles that we have a name for. Isosceles is when you have a triangle like this, and two of the sides are the same. So we make those markings, and that's coming next unit, by the way, where we're going to do a lot of this markings. We're going to use marking. This is telling you that these two sides measure the same. We don't know about the third side, but this one for sure. And watch this. The angles that are across these, like if you were to travel across this side and take this side and travel across, these angles are also going to be the same, guaranteed. Okay. Two congruent sides, two congruent angles. It's an equal sign with a squiggly at the third, right? So I didn't make this up, right? So this means, let's just put congruent. If you want to sound really smart, right, you just say, hey, they're congruent, but it really means equal. That's what that symbol represents. Okay, so you don't have to fear it. It's less writing, math. We like to keep it at a minimum. That's why we come up with all these symbols, right? Don't have to write as much. Equilateral triangle, everybody knows that, I hope. Equal lateral. Lateral stands for sides, so equal sides. So all three sides measure the same. So what does that tell you about all the angles? Every single angle is going to be the same, correct? So we can split, right, all angles are going to be equaling 60 degrees. Because why is that? Well, 180 split into 3 groups gives you 60 degrees. Okay, so every single one equilateral. I don't have to tell you that. The side lengths do not matter. It could be a really large triangle or a really small one. The angles are always going to be 60 degrees. Okay, all angles are 60. All sides are congruent. All angles are congruent. So sometimes that comes in very handy. And a right angle, of course, it just has a 90. That is what you need to have, right? That's the only criteria that needs to be met to use to know that one. So maybe I'll do one upside down like this, so you're not always thinking it has to be a certain way. So that's just a review, and that comes back next unit, so I don't mind reviewing that. Supplementary angles. Who in here knows what supplementary angles are? Try to define it using your own words. Anybody remember? What do they add up to? I don't blame you. Francesca, you want to give it a try? 180. 180. So this is how I don't know which teacher told me this, but I'll never forget. It's right to compliment someone. It's right to compliment. So complementary is an add up to 90. So supplementary add up to 180. Okay. So it's two or more angles whose sum is 180. So the sum means, like, if you were to add them all up, that's what the sum is. It's 180 degrees. So here are some examples. Let's say you have a straight line like this, right? And at any point on that line, you make a dot, and then you cut it. It's being cut like this, right? If this is 50 degrees, right, then this would be what? we know that, maybe I should review this too. Watch this. I'm jumping the gun here. Okay, I need you to know that if you were to take any point along a stretch, and these are basically two separate lines, correct? Two separate lines. If you measure from here all the way to the other side, that's 180 degrees. That's the property of a straight line, that it is 180 degrees. No matter which point you pick along it, if you were to measure from one side to the other, it's 180. It's a half a circle, right? So using this property, we can apply that to anything. So if I were to hone in on this, sorry, I'm getting too excited here. If I hone in on this straight line here, I know that from here all the way to here it should be 180. So if this is 50, then this must be 130, right? These would be considered supplementary angles because they add up to 180. Let's do another one here. What if I had a straight line going this way? Let's pick any point along it. Let's have this and this going. You're like, whoa, right? What's going on there? This is the line I want you to focus on. This, you know, is 180 degrees along that line. So if this is 30 and this is 70, right? So if I know that this is 30 and that's 70, what must this angle be? So summum 80, right? Because 70 and 30 add up to 100, so this must be 80. They all add up to 180. So these three angles would be considered supplementary. So, right, sum is 180 degrees, right? That's the important thing that you need to look out for. So now let's apply this to a triangle. Ready for this? Okay, so let's say you have a straight line, this is the ground, and then make a triangle like this. Just make it look like it. Okay, you have your triangle. Now take this corner here and extend this side. You're basically extending the base. If this problem told you this looks, right, like a, let's say 120 degree angle. If this problem told you that that's 120, it often, right away you can tell that you will be able to bring an angle inside the triangle just by looking at this straight line here. If this is 120, then this one inside here must be 60, right? Now, so the problem didn't give you an angle inside the triangle, but now because you know the property of a straight line, you were able to bring one in, right? So I want you to be very aware of that. It comes your way down the road, okay? It's actually a cool strategy to just bring it in. You just need to know that. Notation, this is important, so make sure you have this. If I had a triangle like this, oops, let's say I had a triangle like, or let's just make an angle like that, and make dots like this, and we'll call this A, B, and C. You have a highlighter. If you wanted to refer to this angle right here, remember angle is the opening, right? There are a couple ways how we can refer to it. You could just say angle B. In that case, you would be referring to this angle right here. You could be referring to this way. This is the complicated one. Just watch carefully. You can start here and just say A, B, C. So you could say angle ABC. Notice the focus is that B is in the middle. Or this is the other way. If you want to start on this side, you could refer to that as CBA. All three of these notations refer to the same angle. And sometimes students find this very confusing. So I would just say read it as it stands. So let's say I give you angle ABC, go to your diagram and go ABC. It must be the angle formed between these 3 points. So it's this angle. So sometimes I tell students just call this angle X, right? And then from now on, you just refer to that as angle X. That way you don't have to do the 3-letter notation, okay? Angles of elevation and depression. I'm not an artist, so don't judge me. So just draw a person here, okay? I know where I stand when it comes to art, okay? So you don't have to think anything there. So let's say this is the eye level. Just go dashed line straight out. Okay, so this is your what we call the horizontal, right? If you were to look at something up, it could be the top of a building, it could be a plane, it could be a kite, a cliff, you name it. If you look at, I'm just going to draw a bird there. If you were to look at that object, right, the angle formed here, right, is called the angle of elevation. Angle of elevation. It's very important that you understand that. It's between the horizontal and the line of sight looking up. That's your elevation angle. So let's pretend, like, let's draw ground under this person, right? Try to make it straight. If you were to look at something on the ground, so let's say you're looking at a bug crawling on the ground, right? You would then be looking obviously downward towards that item on the floor. It could be that you're on top of a cliff, you're looking down into the lake, there's a boat there or whatever. That is called the angle of depression. Angle of depression. I'm just going to do this. I'm going to highlight that horizontal line because that is what they both have in common. What do they both have in common? The horizontal line. There has to be a horizontal line. And this is why I'm telling you this, because don't copy this, just scrap paper here. I'm trying to think of all the mistakes that I've seen in my short career, right? So sometimes students are on top of a cliff. This is a lake, and there's a boat here, right? And they're like, okay, you're on top here. Here's your boat. Okay, so they get this part right. And then they're like, and the angle of depression is 50 degrees. And they're like, okay, it goes right here, 50 degrees. Is there a horizontal line there anywhere? Nope. So you have to bring that in. You just say, okay, I'm up here, so I'm going to imagine a horizontal line going straight, and then the 50 goes here, not there. Okay? Very common mistake. So I want you to be aware of that. Keywords. I think I just want the compass rows here. It's not the full compass rows, but north, south, east, west. So it has to say from left to right, we, not you. right? Get that? We, not you. If it's you, you got it wrong. Some students do get it wrong. So if a tree is due east of you. If a question said that, a tree is due east, that means that if you were to stand here, the tree would be due east of you, right? It means that it's straight, like right next to you. Like if you look east, it'll be right there, okay? So some questions, not very often, but it does come up, and so I want you to be prepared. So if something is due north of you, if you were to look up, it would be straight up, right? Due south, due west, and so forth. So if you didn't know this, now you know. It was a refresher maybe. I know the pandemic has not been ideal in terms of teaching for a lot of teachers. It was survival mode, so I just wanted to make sure you have this all refreshed, especially notation. Like I don't want things like that to throw you off, because it's not that bad if you just know what you're supposed to be doing. Okay, so now let's start with the actual unit. Here we go. New skills, working with the sine law. So you can actually, at the top here, just nice and big, we're gonna use the sine law here. And then maybe in next week probably, or maybe Friday already, we'll start cosine law. So new skills, working with sine law. So basically just reviewing using the trig ratios sine, cosine, and tan, as well as Pythagorean theorem, can solve for missing side lengths or angle measures of right triangles. So that's what you did in the past. But what happens, right? What happens if you're missing measurement of an oblique triangle, right? Sine law, right? There's that word. Sine law can be used to solve for unknown side lengths or unknown angles, right, of an oblique triangle. But this is what the text is not telling you. Sine law, write this down, make sure. Sine law also works with, I don't know why they don't say this, but sine law also works with right triangles. Okay, that's a very important exclamation mark. So sine law works with oblique and right triangle. And here's the basic formula. The basic formula is right here. That's all you need to know. But there's a note. We set up a proportion with one equal sign. Okay? This, because sometimes students think they have to have three things like that with two equal signs. It's not true. What it's telling you, this theorem, bless you, it's saying that the sine of an angle, right, over its side is the same thing as the sine of the other angle over across from that side equals sine of C over side C. So we'll put that to use in a bit and it'll make more sense. But here's something I want you to note. Watch this. Capitals, right here, capital letters represent angles. Lowercase sides across from angle. Good morning. Capital letters represent angles, lowercase the sides across that. I would box this in. So notice this. Watch carefully. Angle A up here. Watch the side. If you travel across and you hit the side, that's side A right there. If you go to angle B and you travel across, the side length B is right across from it, and that pattern continues. That is the norm in math that we label, right, the lowercase letter of whatever the angle is across. So I will just leave it at that. For now. Okay, let's go into our first example on page 261. Okay, always read the question carefully. Use the sine law, it's telling you, right, to calculate the length of side A. So they're basically asking you to find this. Let's go to side A here and put a question mark right under it, right next to it, I should say. They're asking for that. Now, soon we're going to start with cosine law. So I'm always going to assume that we don't know which law we're going to use. So watch carefully. This is how you know for sure that sine law is the one you need to start with. If you have an angle, like you have the 52 degree, and you travel across and you see that you also know the side length across, do this for your notes, right? Okay. Known pair, known angle side pair, okay? And that means use sine law for sure. If you have that, you might have to do some tweaking to it. You might have to do some additional work, but if you have a pair, a known pair, forget about cosine law, it's going to be sine law, okay? So let's do the work and focus in on the details on how I show my work. I will always start with sine of 52. We know we're using sine law, so it's sine of, can I say something? Angles are always glued to either sine or cosine. Angles never show up just like that out of nowhere. You don't just put 52 into your calculation. So sine of 52 over, you put the side length, and for now we're going to add units. Later on we don't have to. Okay, so this is my pair. I start with that every time. Then I go equals. It has to be, you have to have the same pattern, sine and side length. Which side length are we trying to find? Trying to find A. So I'm going to put A down here. And at the top, I'm going to put the angle that's across from it. That's always key, that they have to be across each other. So you set it up like that. So it's a proportion, right? cross multiply and divide. So you go to the right side because that's where your variable is, but you will start here, cross multiply and divide. Right? If you remember that, this is going to be easy. Then you say next line, do not have an equal sign right next to it. Don't do that. You show me the work. A will be equal to, so you multiply these two. Watch up on the screen. These two multiply each other. I tend to start with the side length and then go sine of 72 like this. So as long as these two are multiplying, you're good. Divided by sine of 52. And this is where I all want you to use your calculators to make sure you get this right. This is where I would suggest you get your own, because if you don't get the right calculator and you're not used to the one you're picking, you might be in trouble. Can you just make sure you understand this? Yes, you could have put sine of 72 first and then 16.1, but sometimes calculators, like if the 72 and the 16.1 are next to each other, they get it wrong. So I go 16.8, do that with me, times sine of 72. I hit equal at that point. And then I go divided by, it'll automatically take that answer and divide it by sine of 52. And then I hit equals. And this is what you should be getting. So try it. 20.20, what would that be? 28, right? 28? Okay. I always round to 2 decimals. It could be angle, and we are in centimeters because my side length is in centimeters. You've just solved for one of the sides. Yeah. You got what? Okay. Should be the angle sign. Oh, like you actually entered. Okay. If that works, then should be fine. Like a degree symbol, you mean? Okay. Check it out. See if it works every time. Like if you have a couple and it works, then go for it. Yeah. I've never used it myself. We're good? So this is how you solve for a side, folks. Let's keep going. I should tell you how many marks you would get on a question like this. You get 1 mark for setup, 1 mark for the work, and usually 1 mark for the correct final answer. And down the road, you might get a 4th mark if you need to pick between sine law and cosine law. Okay. I'm going to extend here. So pay close attention, please. What if this question asked you to find side C? Can you do that? The answer is no, because look at across from that side. You don't know this either, right? Both are unknown. You can't do it. But is there a way to find this angle perhaps? How many angles do we know? 2. It's easy to find the 3rd one. So here you go. Write this down. That's why I left this whole page blank. So calculate length of side C. That's going to be like an extension. I'll say this, need angle C first. Okay? So I will say that angle C is going to be 180 minus 52 degrees minus 72 degrees. And that gives me, if you do this, you get 56 degrees for angle C. I'm going to underline that because it's not my final answer, but it is a number I need to know. You need to know the angle across the side you're trying to find. I'll repeat that one more time. You need the angle across from the side that you're trying to find. Okay? So watch this. This is going to look very familiar to you. I'm going to start with the same pair that I knew from the very beginning. All right? This is the pair I knew from the very beginning. I circled it on my diagram. But now, on the other side, instead of sine of 72 like before, watch this, right? Before I had sine of 72 to find A. Now I'm going to use sine of 56. Sine of 56 to find which side? Side C, which is across from that angle, right? And then the story repeats. Cross multiply and divide. Please show this step in between. It gives you, like, I actually want that to be there. Okay. 16.8 times sine of 56 divided by sine of 52. That's 17.67 centimeters. That's my final answer. Okay, if you have a highlighter, where's my yellow highlighter? Oh, here it is. Let's do this all together because it's really the highlight of everything we do. You identified this pair, right? You knew immediately that we're going to have to use the sine law, right? Because Mr. Dirksen said so. For now, later on, you're going to figure it out for yourself. That pair shows up here, and that pair shows up again here. So we use that, right, to get us started, and then I fill in the rest. But please never just have, for example, up here, just have 72 show up. Some students set this up, and then they just put 72 degrees. That's it. No sine in front of it. Remember, an angle always has to have sine or cosine glued to it, right? So remember that. So when you find all, like we now know all three angles, all three sides, right? We have solved the triangle. If you know all three sides and all three angles, you actually have, when the question says solve the triangle, it's asking for that, okay? Another side note. I'm going to actually block this off here because I don't want to mix the side note with the work. I will just say that longest side it's always going to be across. The longest side in a triangle is always going to be across the largest angle. I think you would have to agree with that, right? Like, I will show you in a bit. And the shortest side is always going to be across the smallest angle. So if you do your work and you see, like, wait a minute, how come I have like this answer, but it's across the shortest angle of my triangle? Doesn't make sense. Sorry, the smallest angle. Did I say shortest angle? The smallest angle. Like, why is that, right? You should always be able to check. In this triangle, which angle is the largest angle? Just look at the numbers. Yeah, A, yeah. Is the side across from A our longest side? Let's just do that by inspection, right? A is 20.28, C is 17, and B is 16. So yes, A is the longest side, which is across the largest angle, right? So it's kind of like a way to check, right? Don't just blindly trust your work, okay? All right, so I'm going to stop there for a bit. I don't know if we're going to get to solving for an angle today, but I want you to practice, right? Learn math by doing math. So on the next page, you have 3 triangles. And I will add to this, calculate the length of the indicated side. We're not going to do that, of all sides. So scratch this, of all sides. Okay, I'm going to ask you to do that. I was able to fit in, like if you use either side of this, of each triangle, you can actually solve for both sides on either side of this triangle, and then do the same thing for B and the same thing for C. Obviously, they're all going to be sine law, guys. I'm not going to do cosine law yet, right? So you know these are all sine law. Give that a try. So basically, I'm asking you to solve for side Z and for side X, right? For this first one, you have to solve for both of the unknown sides. So you start. You pick which one you should be doing first, right? Maybe it's better to start with the one they're asking you for and then solve for the other one for now. Go ahead. Some of you are still working, and that is fine. You can keep working or just follow along. Make sure you got the first couple right. I will give you the answers to all of them in a bit, so then you can check, right? Again, this triangle, you should notice what kind of a triangle is it if it's bigger than 90? Or maybe remember the name for it? Obtuse, yeah. So this is an obtuse triangle, no big deal. Sine law, cosine law can work with that. You have this pair, you should immediately realize you have to start with sine law. You can only start with one of them. Right now, all you know is sine law, so of course that's going to be it, right? But it's going to change. So I use that pair almost without doing anything else. I just use that pair. Let me just get that right there. And we're meters. And on the other side, I will fill in what I need. It's your best choice right now to find Z, right? Because it's across the angle you know. So I'm going to say, well, if I know 15 degrees, sine of 15 that is, I can find this side length, right? And cross multiply and divide. So Z is 1794.3 times sine of 15. I saw a lot of you doing this. Beautiful. Let me zoom into that a bit. If you're writing this down, so you cross multiply and divide, and you should get, if you do this right, if you round correctly, you should get this. Okay. We round to 2 decimals, angles, sides, it doesn't matter. Your final answer is 2 decimals. Now, if you are more comfortable multiplying these two and getting a number and then dividing it, make sure you use 4 decimals along the way. Don't just do 2 decimals here, 2 decimals there, and then 2 decimals again. You're rounding too soon, okay? Now, I'm going to focus in on the side x. So you can actually put lowercase x there and say, I want to know that as well. So now I'm going to go over to the other side, and I'm going to start with the same pair. That's how I do it. Not everybody needs to do it exactly my way. There are variations of this, but I kind of to stick with one method so I'm not throwing you off. What do I need to do this? I need sine of angle x, right? So there's an extra step necessary here. I will do that up here. Angle x will be taking 180 and subtracting 132 and 15 from it. Angle x is 33 degrees. And that is what goes in here, right? Because x is now 33, I can find side x, no problem. Cross multiply and divide. So that's 1794.3 times sine of 33 divided by sine of 132. So that's 1315.01 meters. We are in meters, so whatever units are present, that's what you use. So there's that. So those are the two that were given there. Okay. So here will be the answers. So I'll put them down next to each one of these, so you can check. So side M here would have been 12.40 centimeters. Side L would have been 17.64 centimeters. Write these down so you can practice them if you don't have them yet. And then here side P is 54.29 centimeters. And side R is 31.58 centimeters. Okay. So write them down quickly. Let's do one example where you solve for an angle, okay? Before we go today. So write this down and let's go to the next page. Some of you are starting it, and I don't mind that at all. If you try questions that you may or may not be ready for yet, it's a good challenge. I will never yell at you if you go ahead of us, okay? So feel free to do that. All right, let's go to page 263. 263 looks like that. Okay, so example 3. Let's go up top here and just make a little note. What's my heading there? Sine law to solve for angles. Write that down, okay? Sine law to solve for angles. So this is specifically showing you how you would solve for an angle. The start is exactly the same. It's just the end where you need to be careful. So I have my pair. Sine law. You'll never forget that, I hope. Which angle should I start solving for? There's only one right answer. Not Kim J. You can't answer. Let's see if you answer. Anybody? A? Yes. Watch carefully. This is lowercase a, by the way, because uppercase is there. This side is known, so the only angle you can start solving for is angle A. That's the only one because it's across from it. C is like nothing. You don't have the angle, you don't have the side. So let's start with this. Let's start with our pair. Sine of 81 degrees over 123.2 meters over. We want to solve for angle A, so watch carefully. It's not just A, it's sine of A. Sine like angle always has to be glued to either sine or cosine. It never just shows up like that. And side A is 91.6. I don't know what happened there, so let's try that again. 91.6 meters. So now you have both sides, but you want to find the angle. And notice how they're lined up, right? The angle is lined up with the angle, but there's sine both sides. So here we go. This is your unknown. So you start here, you cross multiply and divide, just like before. Cross multiply and divide. So the big temptation you have to resist is to just get rid of that sine. Look at the whole thing as your unknown. So you say sine of A is equal to, don't worry about it too much. It kind of looks scary, but it is not. It's like watching Jurassic Park for the first time. It's scary the first time, but then it gets less scary as you watch it again, right? So don't worry about it too much. Watch what I do here. This is my way of doing it. I go sine of A. Actually, no, this is the shortcut. My bad. I was just thinking. So we're going to figure out what this is and write down the decimal. And it has to start with 0. If you get something that isn't 0 at first, it's going to give you an error. You did something wrong. You got to go back. Don't call me. Don't call me. I'll say I can't answer that. Right? You did something wrong. So let's type that in. 91.6 times sine of 81. You might have a different calculator. You might have to go 91.6 times 81 sine, hit equal. Okay, so you know who you are. Divided by 123.2. And watch this. I'm going to write this down. 7,344. Okay, that 3 turns into a 4. I'm using 4 decimals, right? Use at least 4 decimals. If you use them all, that's even better. So what have you just figured out? That this ugly piece here really turns out to be a decimal. Are you ready for this? So 1, right? 2, 3, and then you go like this. Angle A. So I dropped the sine. Do you notice that? It's not any more sine. You have to make it show up like this on the other side. Inverse, sine inverse of 0.7344. So you plug that in there. And it's as if that sine shows up on the other side, even though it's the inverse, right? But it's kind of made its way over, and A is now completely by itself. Let's see if you can type this in. Ready for this? You got to use shift or second or something on your calculator. Shift sine of 0.7344. If this isn't working for you, I will show you a different. So this is 47.2. That 5 turns into a 6 degrees. We'll do the rest tomorrow. If you have a different calculator, if you have a different calculator, listen up. You have to go 0.7344 second sine, and then it's going to give you the inverse. Okay, you have to go backwards if you don't have a two-liner. Okay, thank you guys.